Hi. We will be talking today about about a system of equations, and there's nothing really special about it except that a system of equations is when you have more than just one function that's present. So, what do you see? I see an exponential equation that's positive, and the y-intercept is 200. I see a negative quadratic function with a y-intercept of 450 and a negative linear function with a y-intercept of 650. As you can see by the labeling here, the y-axis represents dollars and x-axis represents days. And we're going to be thinking about these functions and what they mean. So if this is a picture of you and your two friends, what you have in your bank account, which one would you want to be, which function would you like to represent you on day one? Well, on day one, if we're talking money, I'm not going to go with the exponential because I only have like $250. I'm not going to go with the quadratic because I only have like 550. But I would go with the linear because I've got $600 in the bank account at that point. And the y-intercept you can see not only by the graph, but also, remember, by the equations. So this is the exponential standard form, which means you start with $200 and you're gaining 25% every day. This is the quadratic. This is saying you start with 450 and then you're losing money each day. This is you start, I see a problem here. Just a minute. Alright, I had to redo that because this is a linear in standard form or in slope-intercept form, and we're starting with 650, losing $50 each day. So overall, the linear is negative and the quadratic, as always, starts positive and then switches to go down. It's concave down. On day 3, who would you rather be? I'd rather be the blue function because you've got $600 as opposed to the linear function or your friend. They only have $500, and then this green one, they only have $400 on day 3. On day 5, go to day 5, go up. Well, linear is still losing money. They got 400. Quadratic started losing money. They got, I don't know, 475. And the green, the exponential, suddenly has about 600. Technically, what these points are called right here, and right here, and right here, and right here. We can see that they're intersection points, but those are called solutions. That's when the functions, like right here, the green and the red function will be the same amount. The blue and green, same amount at that point. Red and blue, same amount at that point and at that point. And then over here there would be another solution, but it is just off the graph, so we don't know. This one, I guess I jumped the gun. When does A and B give you the same amount of money? B and C, and then A and C. Well, A, if we're saying that's the exponential, A and B will give you the same that's right here. B and C will give you the same here and here. And A and C will give you the same right here. So if the question is, what's the solution to this system, or what is the solution of the following system? For A and C, I would say, Well, that's kind of tricky. Here's 3.5. Here's 4, so maybe 3.75, comma, and then so 3.75, comma, maybe 460. Seems to be just a little bit above the halfway mark. So $460. Remember, this is the dollars and this is the days. So at 3 days and a little over 3.5 days, you're going to have the same amount of money, which is going to be $460. We're also going to review just a teeny bit, which I've kind of integrated into this so far, but just a little bit of review about the different functions. So we got a linear, which is the red, it's negative. The slope-intercept form is y equals mx plus b, where b is the y-intercept and m is the slope. Whoa, I did it again. Shoot. Okay. Quadratic standard form is y equals ax squared plus bx plus c, where c is the y-intercept, and the a value tells you whether the parabola is concave down, like this one, down like a frown, or concave up if it's positive, like a smile. And then exponential standard form, this has been a minute since we've talked about this. It is y equals ba to the power of x, where b is the starting, or the y-intercept, a is the growth rate, or growth rate, basically, is it a growth, is it a decay? Remember, if it's above 1 like this, it's a growth, so it's going to be going up, positive. If it would be below 1, then it would be a decay. Alright, I hope you enjoyed it. Quick review, quick intro. Let's get to solving these systems.